Hey folks, so we're going to be, I'm Bryce, this is Joel. We're going to be talking about API review and some tools that we've been working on to potentially make that easier for Kubernetes and beyond. So today we're going to talk about why do we do API reviews? What do we think about when we're doing API reviews? How can tooling improve that experience? And then we're going to ask for you guys to give us some help with those tools. Who are we? Like I said, I'm Bryce. I started working in the Kubernetes ecosystem in March of 2022. I'm a former operator framework maintainer, so I worked on the operator SDK and the operator lifecycle manager, maintaining operator lifecycle manager v1 and helping build operator lifecycle manager v1, or maintain v0, help build v1. I am recently onboarded with Joel as a OpenShift API review team member in January of this year, and I am currently working on the OpenShift control plane. And hand it over to Joel.
If you don't know me, we're going to switch back and forth. Goes 1, 2, hello. No. 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 I assumed so.
It is not.
How do I turn it on? Hello. That's better. Hi all, I'm Joel. I've been working in Kube since about 2017. You'll find me normally looking at things like cluster API and controller tools, but I'm also a SIG Cloud tech lead. I've been doing OpenShift API reviews since about early 2022, and I've recently taken over trying to build a review team within OpenShift. So before we can talk about why we're building tooling, we kind of need to understand what the problem actually is. So why do we have API review, and why is it so complicated? So there's a lot of things that we're trying to achieve in API review. These are just a few of them. So over the last 10 years or so, there's 2,200 or so lines of Kube API conventions that have been written. This is learning from previous mistakes we've made, APIs that didn't evolve well, APIs that were just a bit awkward for people to use. We also look at the changes. So some changes are fine, they're additive, we just can make those. Some changes are breaking, we don't want to have those. Some changes are breaking, but we might actually reason about being acceptable. So that's something we have to keep an eye out for. We're also looking at consistency. By reviewing a huge and widespread group of APIs, we can try and build lots of different APIs that kind of look similar. And that's beneficial to end users because it means they'll have familiarity when they jump from one API to the next. An example of that might be the enums in Kube APIs are all Pascal case, for example. And finally, adding an end user perspective. It's very easy as a developer working on a project to forget that other people exist in the world and build an API that makes perfect sense to you but is completely incomprehensible to anyone else. So to paraphrase Jordan, I don't know if he's in the room, but one of the best things about being an API reviewer is that you can just be like, explain this like I'm 5. Over and over again until eventually you get to a point where you understand the API and you can therefore help add that end user perspective of, okay, this is going to need to change to make this actually usable.
Yep, so in order to review APIs, it sounds like you need to have deep knowledge of the existing API conventions. So you need to know when to apply them, why they have been made a convention, and why they make sense. You have to have a deep understanding of how your API changes are going to impact your clients. You need to have a deep knowledge of any of the existing API patterns. And you also, when people bring new APIs to you for features that you may not have heard about, you have to be able to ramp up pretty quickly on what that feature is doing, what the anticipated end user use cases are, and how you can potentially influence that API based on the conventions and the knowledge that you have of the feature. So we're going to go deeper on some of the things that we consider during an API review. So some of the important things, we're going to split this into 2 sections. There's implementation considerations. So this is like when you're writing your APIs in Go. If you're familiar with building CRDs and using things like KubeBuilder or ControllerGen, you know that there's KubeBuilder markers and stuff that can represent like validations. There's that side, and then there's also schema considerations for how is your Open API schema generated for things like a custom resource definition. So some of the things on the implementation consideration side is, like Joel mentioned, consistency. You want to consider past mistakes, serialization. Serialization is a big one, understanding how your types go from structured to unstructured, and are passed to the Kube API server when someone makes like a kubectl apply call. For schema considerations, you want to think about invalidation of any previously valid values. What are the impact to your users there? In general, client expectations, who's reading, who's writing your APIs, and then versioning. There's strict versioning guidelines, and there's a whole lot of complexity. If anyone's tried to upversion their CRD, you probably have gone through a lot of work trying to understand what are the constraints for versioning your API.
Okay, so I'm going to talk through a bunch of these implementation considerations. So we'll start off with some of the consistency things. So something we're trying to do in Kube at the moment is make sure that optional and required are on every field, one or the other. So whether a field is optional or required influences a bunch of things, like if we need to document what happens when the field's not there, it also influences things like the serialization. So we need to make that an explicit choice when we're designing APIs. One of the smaller things you might notice is around comments. So in Kube APIs, the comments should start with the JSON tag. That's the field name that end users are familiar with. And so when they do something like kube control explain, they get the right version of the field name and it looks familiar to them. Another thing would be list types. So every list in Kube should have a list type on it, be that atomic, where the whole list is updated as a single unit, or map or set, where multiple writers can write different elements within the set in the lists. We need to make sure that every single list type is there, because if we forget it, it becomes atomic, and then potentially later we realize that's not what we wanted. There's also, as I said, lots of mistakes we've made in the past and things we no longer want to do. So things like durations. Go durations are great if you are writing a Go client. But if you're writing Python, you have to extract that using a regex. It becomes very complicated. It's preferred to do something like foo seconds, where we use an integer type, the units are in the name, and no one has to do any complicated parsing. We try to avoid maps as much as possible for lists of objects, preferring a list of named subobjects. This maintains that the keys in the serialized object are actually fields and not just free-form text. Booleans, lots of people have different opinions on Booleans, but over time, lots of occasions, they don't age very well. You can only ever have two states, and what you end up seeing is you have two sets of Booleans, where one is only valid to be set when the other one is set to true, and it just becomes confusing as to which fields are actually influencing the behavior at that point. So it's preferable to use an enum and use descriptive values instead. And finally, phases. Phases in early APIs, they were single string field. There was nothing expressive about them. So when did that phase kick in? Are there any errors or anything associated with it? What else do I need to know? Can I transition backwards through phases? This didn't work, it didn't evolve well, and so now conditions are used instead. Serialization is also another complicated thing. So serialization is basically how do we go from the Go type to what's in the JSON. To understand the right thing here, to understand how serialization works, you need to think about things like pointers and what the zero value is. So this would all be very simple if every single field was a pointer, because then you have the explicit serialized intent. No field that wasn't particularly set would be in the serialized object. But that is then risking lots of nil pointer exceptions. It also doesn't work for some types. So in lists, for example, are quite complicated. In Proto, you can't distinguish between an empty list and one that was unset. And also, to make this more complicated, the answer here depends on whether you're reviewing a CRD or a built-in type as well. So here's a bunch of examples of how to serialize a string. I'm going to focus this on the CRD side because it makes it a little bit easier for the moment. But starting in the top left, string without emit empty, this is what you would normally see for like a required string in a Kube API. The Go client will always serialize the empty string. There's no way not to send it. But is that right? We don't actually know in this case whether the empty string is a valid user choice or not. If we move and add emit empty, then there is no way to send the empty string, which again might be correct, but we don't currently know because we've got no validation here. Moving across to the pointer version on the top right, now you can send the empty string, and that must be an explicit choice. That's fine, but we, again, don't know about the use case. So in a CRD, at least, you would add these Kube builder markers that are on the bottom row. So in the bottom left, minimum length 1, this actually works well for a CRD. There's no way to send the empty string, but we don't need to, and the validation at OpenAPI would reject anyone sending an empty string anyway. If you are using an unstructured client, you would still be able to send it, but you'd get an error saying min length 1. For a Go client, unless you set something explicitly for the field, you'd get like a this field is required error. But what about with 0? There's two examples here in the middle and on the right. In the middle, we haven't got a pointer. Again, there's no way to send the empty string, so in this case, we actually need to move on to the right-hand side where we can send the empty string because it is a valid choice. Serialization gets even harder when you start thinking about structs. And the question here is there a semantic difference between the struct being completely unset or empty? So there are some use cases where an empty struct is correct. Empty dir, for example, or a label selector sometimes you see where the empty object means match everything. So if you want that behavior, you then have to think about, well, would the empty struct pass validation? So for that, are there any required fields? Is there a min properties? Do the fields emit correctly? There's a lot to think about, and this has only just recently got more complicated with emit 0. So I hope you'll all agree and bear in mind we're scratching the surface of the conventions here, there's starting to become a lot to think about, which is why we started building Kube API Linter. So Kube API Linter came out of a bunch of conversations in Salt Lake last year, and the intention of Kube API Linter is to take a lot of this mechanical stuff that we can gather from the Go types and commoditize it so that we don't have to think about it. The goal being that API reviewers can spend more of their time focusing on the important parts of API review, like how is this actually going to work for end users, and not these mechanical things. It's built as a Golang CI-lint plugin, which means that if you already have Golang CI-lint on your project, you can just add it straight in. There's a whole bunch of different rules, which I think is the next slide, all of which you can pick and choose which ones you do and don't believe in, because trust me, I've dealt with lots of different communities who have different opinions. And if you want to see examples of it, there's a whole bunch of communities that are taking this on. We've got some examples in KK now. Cluster API have been using it on their V1, V2 APIs. I know Gateway API and Q are also integrating. So far, we've implemented 28 different rules, covering lots of the stuff I already talked about, like the comments being right, the tags being there for the list type, the serialization, that's all in there, and many more. There are currently around 10 open issues for other linters, and if there's anything that's not on here and not in those open issues that you want, I would definitely appreciate you opening an issue and explaining the use case. And just as an example, if you've seen the Golang CI-lint config, here's an example of how to configure CAL there. You can either build it into the Golang CI-lint binary itself using module mode, or you can build it as a Go plugin. This is an example of the Go plugin. And as mentioned, the blue and orange boxes are how you actually can configure CAL itself with different rules that you want to enable and different configuration for those rules. And just for some examples, I had to play with cluster APIs configuration. Here's a bunch of examples of it actually coming out of Golang CI-lint, marking things like the list type marker being invalid, or you haven't thought about the serialization of this struct. So with Kube API Linter now, we can start enforcing the consistency, make sure we don't forget things like the optional required. We're reminded if we try and repeat past mistakes, we no longer have to think about the complex issues, and hopefully people can now self-service their API review a lot more, and the actual API review team can focus less on the mechanics and more on the user experience. But it doesn't solve every problem.
Yep. So Kube API Linter is great for static analysis, but it doesn't look at changes across, like a PR that comes in, changes your API surface. So one of the things to think about for schema changes, or a few of the things to think about for schema changes, is when you make changes to your validations, it's great to have admission time validations because you get faster user feedback cycles on invalid values. But when you change those, they're technically breaking changes. Some of those breaking changes are more tolerable than others, so they're generally seen as like backwards compatible. There is ratcheting that now exists in Kubernetes. You should use it carefully. Ratcheting is not a cure-all, but it can be helpful if you do need to tighten your validation. You need to think about your client expectations. Once your API is out there, you're not going to control how your users interact with your API. You can provide suggestions, but once it's out there, users will use it how they want to use it and whatever their workflows are. Schema changes generally need to be backwards compatible and prevent breaking older clients of your API. Versioning, when you are versioning your API, like a CRD, Kubernetes itself has strict API versioning guidelines. They are applicable to CRDs as well. One of the big things is that all served versions need to be backwards compatible when you're not using a conversion webhook. There is a caveat there. But if you're not using a conversion webhook, all of your server versions need to be backwards compatible. And the key point, regardless of conversion webhook or not, your data must round trip without data loss. So we're going to look at a couple examples here. We're going to start with just a couple spec properties for, we're going based off of like a CRD. So we can see here we've got size that defines some number of replicas. It's got a maximum of 3, minimum of 1. We have a mode where it's an enum with can be managed or unmanaged, and we have size marked as required. So this is like setting our baseline. If we go and we look at some validation updates here, we see maximum increased to 10 from 3, minimum has gone up to 3 from 1. We now added a new enum called partially managed, and we have now made mode required. So is this compatible? So one of the things to think about here, when you have maximum increase, so maximum increase and enum partially managed, right? That's generally seen as like a loosening of your validation. You're now allowing a wider range of values. However, that might break some clients, right? What if you have a reader, what if your API is mainly read by people who have created some sort of automation? If you increase that maximum, they might not understand how to read a maximum beyond 3. What does that mean to them? What does partially managed mean to them? If you haven't defined how they should handle and changes of values, they don't know how that's handled. That is technically not a backwards compatible change. For something like adding the required mode and increasing minimum to 3, that's a more restrictive validation. That can be okay for readers that don't care about that, but for writers that have workflows that have already defined, for example, in the minimum case, if there's somebody that already has a workflow that writes 1 as the minimum, or writes 1 as the value here, it's allowed from the original minimum, that workflow is now broken. Same thing for adding mode as required. Any workflows that were originally using mode or were omitting mode are now broken because mode is now required. So then we can go and we'll look at an example for versioning. This example is going to be without considering conversion webhook, just for simplicity. But so we've got a V1 here, we've got a few fields. It expands kind of on the last example, but we added a container port field. So we go through here and we see we removed that container port field. We did a similar thing, increasing maximum minimum, adding a new enum. And we want to know, is this compatible? Well, from Kubernetes perspective, when you're not using a conversion webhook, this wouldn't round trip successfully because you have data loss potentially. If you have somebody who had set container port and they can now go and request V2 of that API, or it now becomes stored as V2 of that API and they request V1, the container port gets dropped. It becomes empty because you didn't have it stored anywhere. So these are some of the kind of things that we are thinking about when we're looking at versioning, when we're looking at some of the schema changes. And so we started working on Certify. This was something that similarly came out of Salt Lake City. OpenShift had originally had something that they called the CRD schema checker. When I was working on Operator Lifecycle Manager, we were looking at how do we upgrade various packages, or take an operator, go from one version to another. How do we statically check, are there any potentially breaking changes to your CRDs when we're making those updates? So some of the work from there and some of the work from the CRD schema checker, we kind of combined it, and it's now Kubernetes SIG Certify. It's a standalone binary, then the goal is for it to codify schema change compatibility based on the Kubernetes API conventions. It can be used in any CI/CD systems like GitHub Actions because you can pull it in as a standalone binary, have a configuration file. The Operator Lifecycle Manager project is currently using this for their APIs in CI, and they also import it as a library so that they can do those static checks when they actually do runtime analysis of upgrading a package and checking whether or not that CRD would be compatible. And it has same version, so that first example we looked at where you're making a schema change on, say, a V1 API, you add or change some fields against the V1 API again. And it also implements served version compatibility with the ability to set it to ignore if you have conversion webhooks enabled. So we have about 17 different rules. We have another 11 in requested open issues. and this is an example for the validation change compatibility. You see new required fields, new allowed enums were added, the minimum was increased. And here, this is for the served version compatibility. You can see that it's checking v1 to v2. It's specifying what fields it's all errors in. And yeah, so to wrap up.
So yeah, both of these projects, they're about a year old. They've come out of Salt Lake last year. The aim for both of them is to try and make the API review process easier and bring API review to more projects across the ecosystem. So if you have a project that you're working on and it has either a Kube, like aggregated APIs or CRDs, whatever it is, you should be able to use these projects with your, should be able to use these tools with your projects to try and improve that API surface. There's lots to do on both projects still, so please do help us out. If you do find issues with it, we'd love to hear about them. So we're trying to kind of go for the early like 0.10 releases soon on these projects. So yeah, any bugs we find out we can fix before then would be good. And yeah, there's a tracking issue for the KK integration if you're interested, which is on the bottom of this slide, which you can find uploaded. And I think we've got just shy of 10 minutes for any questions you might have.
Yep.
Of course, Tim has the first question.
Hey, thanks for this. Thank you for this. It's challenging stuff that's really important. And as somebody who feels the toil of the API reviews, as I stand next to Jordan, who does 10 times as many as I do, thank you. More observation, I guess, than question. There really is no such thing as a compatible API change. Like, strictly speaking, every API change is a breaking change. If you accept Hiram's law, there is a client somewhere who depends on every single exposed behavior of our system. And you called out the example of like, well, what if they don't know how to do 10, they only know how to do 8? As a project, we have sort of defined necessary and acceptable risks in our conventions. We focus compatibility mostly on the writing client as opposed to the reading client. But increasingly, I'm looking over at the network policy table over there, we've been looking at softer conventions that maybe we should codify more around when it's important to make it obvious that there's something that you don't know as a reading client. So for example, adding a new field, right? If you add a field, a backrev client may not know that that field existed and it may do the wrong thing, right? Well, there are times when that's really important, like security policies, where you want to say, I'm going to make the API a little bit more baroque in order to make it more obvious that there's something here and you don't know what it is. Taken to its extreme, it's ridiculous, but in surgical cases, it's very important. So I want to call that out as something we collectively should probably think about how to codify.
Yeah, absolutely. And just that's one of the key things that I think in terms of any schema changes that you're making, you have to consider your particular clients. So the Kubernetes API conventions are like a good starting point, especially for any projects that are doing layered things on top. And so that's something that, like, with the operator framework, we took inspiration from both Kubernetes and OpenShift API conventions, and we kind of shaped some of the rules of the tool, like Certify, to what our use cases were for who's reading, who's writing, whose workflows are we willing and not willing to break, and determining what of those always those always incompatible changes, which of those are we willing to make for different user experience.
The issues that you called out, Tim, are some of the issues we were trying to address with node declared features, specifically for the control plane to node boundary. And I wonder if there's some sort of generalization of that, or like a way that we should think about hoisting that up into the API machinery, so that it works with clients other than just the node.
Sorry, just one quick response. I think one of the biggest mistakes we made is in dropping unknown fields, because it makes it impossible for a backrev client to know that it doesn't know. So I wonder if, that's going to take a large drill rig to get to the bottom of that problem, but that may be worth spending time on.
I think we don't drop unknown fields by default for CRDs anymore. Is that right?
No, we do.
They do.
Oh, okay. Can you turn it off?
There's preserve unknown fields.
Okay,
so you
yeah,
can turn it off.
that's what I was thinking. So what you were saying about better guidelines or whatever, network policy API is running into this. Gateway has had this problem forever. They've been thinking about it. So yeah, we probably do need to get some people together to figure out what the right approach here is.
There's a question in the corner over there.
Primarily for sig-api, have you thought about some of the more like advanced validations, like cell validation?
So I can take this one. So we have kind of thought a little bit about that. There's right now the checks that are within Certify are base level checks. We have not yet delved into some of like the how do you handle like any of one of those kind of things yet. For cell validations in particular, one of the things that we're hesitant about is whether or not we can actually determine whether or not you've made a tighter or not validation. I think probably initially to start, it'll be you made a change. Do you want it to be a warning? Like, how do you want it to show up in your CI system to let you know, hey, a change has been made here. You should verify that it hasn't been done in a broken way. If there's a way that we can better evaluate that, I think I'd be open to hearing that and getting that kind of check implemented.
We had the same problem in crossplane. I prototyped something last week that's very similar to sig-api, but more like the OLM style, like a library that checks as you update your packages. And I just was like, yeah, if you change your cell validation, it's a breaking change.
Yeah.
Don't look at it. It's a breaking if you change it.
Yeah, we have it's on our roadmap to also do patterns because you can do like regular expression patterns. I thought through like you could in theory have like an SMT solver like determine are there things that were compatible with the old that are no longer compatible with the new, but that's like a very expensive process. Do you want to actually be doing that kind of logic? Right. There might be a way that maybe you could have some sort of configuration option within the tool to say, you use the expensive process, don't use the expensive process, but yeah.
Right.
So me again. So I spend most of my time looking at built-in APIs, not CRDs. One of the projects we've been working on in the built-in space is moving towards declarative validation. I know you guys know, but for the room, the goal is to move away from these handcrafted validation rules into declarations about the schema. Describe the data that is supposed to be there and let the machine generate code or rules for implementing that. So the goal for cell validations would be to make them go away, right? Everything you do in a cell validation, we want to find a general way of describing that isn't relying on nearly Turing-complete language. There will be exceptions, right? We understand that there's going to be crazy things that people do exactly for one API, and we're not going to codify that into some new tag, or that we don't want people to copy, so we don't want to build machinery to copy bad things. But the goal with cell is to make it rare and special.
That makes sense. Thanks.
Kind of along that line, we kind of built out CRDs and built-in types somewhat independently. There were some of the same people working on both, but they are mostly independent code bases that in some cases went off in their own directions a little bit. Which makes me think that there are probably simple differences that we could think about rectifying, maybe by adding things directly into what CRDs can do. Have you started to identify cases like that? And
so one of the things with the cow configuration is, at the moment, because we have a lot of markers in QBuilder that aren't expressed in DV, we are finding that some of the rules we're building just don't work for built-in types yet. So I am kind of observing these, and I'm very keen as we kind of progress with the DV project to bring a lot of these things together. I have been debating with Tim for a long time about optional and required, and I'm hoping we can have a good chat about that today. That's like a prime example. Like the way that optional fields and required fields work in CRDs is the presence of the key. If you look at it on a built-in type, a required string means it has length 1 or more. That's not what required actually means in OpenAPI. So maybe those are some of the things that we can iron out through this process, but I think there's a lot of work there. I think we're basically at time, so if any further questions, I'm going to go outside. I guess Bryce will follow me.
Yep.